Now here's a job, and guess what? With our jobs, we have the first task and the second task and the third task. So with our jobs, we also have a series arrangement. So if I want my job to go right and I fail that task, the job can't go right. Now, the machine will go, I press the button and it'll turn. It'll work for a few days when it could have gone for a year's trouble-free. So, yeah, we can make machines work, but they should last trouble-free for their life. And if they don't, then it's because something's been amiss in possibly the repair process or the operating process. So the whole point here, the point here is our jobs are all series arrangements. Our machines are all series arrangements. Our production plants are all series arrangements, which means any link in the chain will fail the business. Now, whenever I bring this slide up, I always challenge people to say, are you happy with what you see there? Is there anything there in that picture that bothers you?
I see a hammer, that bothers me.
Yeah, a hammer and a roller off to one side there. So suspicion he's knocked the roller out with a hammer. These bearings, of course, are precision machines. They're precision now. They're down to sub-microns in terms of perfection. There's emery cloth. Here, they're emery cloth. I suspect he's polished the bores. Now, the interference fit isn't any more the same. And his gloves, those gloves, so that emery cloth he's used to polish and all the rubbish that came off and all the fine particles that got rubbed off by the emery are now on these gloves. So he's going to move that rubbish across all his bearings. What else do I see here? I see here air hose. I see down here bearings waiting to be used or perhaps rebuilt. Hang on, so if he blows down all this rubbish he's put on here with his gloves and it gets blown over to these bearings here, these bearings go into the machine that they're being rebuilt for, then that machine's going to fail from the wear particles that he used emery to clean the bore. I was taught to do this. This is how I was taught to maintain bearings in my trade. I was an engineer. As a maintenance manager, maintenance engineer, I would walk through countless workshops and walk straight past this. This company is failing its own machines because this practice is destroying the bearings that will go into those machines. So the company practices are leading to the company's machine failures. So companies, in my eyes, are breaking their own machinery. They're failing their own machines because if they're doing rebuild practices as this picture is showing, then it is going to naturally cause a failure. This is a process choice. Some manager in this company chose to repair bearings in this workshop in that way. It's a process choice. The process outcomes are then going to be on a distribution. That process will have a distribution. It may not be normal, it might be something else. The point is, over here is failure. And they will have failures because of those practices. It may not happen every machine, but the point is the practices will create a chance of that failure to occur. Like I say, all my career, that would have been okay to me. It wasn't until I began looking to see, it wasn't until I began looking to see what makes this part reliable. How do I keep this reliable and that reliable and that reliable and that reliable? I began to look and say, you know what, that's impossible. If I adopt these practices, I cannot have high reliability in my plant because they are failing the parts that make the machine go around. Then I began to think, well, what does this mean in terms of the company and its management and its engineers and its supervision? Because this guy is just doing his job. This poor fitter is just doing his job. It's what he's taught to do by his previous trade people, and it's what he's been taught at trade school. And the engineers that go to that workshop, they don't see it either. So the engineers don't know they're destroying their own plant. The supervisor doesn't know they're destroying their own plant. The supervisor in charge of this guy doesn't know this is going to cause his machines to fail, because if he did know, he would have stopped that. Engineer doesn't know, supervisor doesn't know, manager doesn't know, and the CEO sure as heck doesn't know. And I was the same until I was 52 years old. I've been an engineer for 20 years, and I'd walk through that shop and it wouldn't bother me at all. And yet, this company destroys its own machines. And nobody in the company even sees it. So if you go to a shop and this is what you see, then they are failing their own plant. And it means to change from this culture where it's breaking their machines to a culture where it's a clean place, proper practices, proper gloves. That's a totally different world. You know, this guy's been taught from trade school to do it this way. And his bosses have as well. And it's been wrong from the beginning. Been wrong from day one. And we've got to change that. Got to change that. Otherwise, nothing will improve. Can't improve because the process they're using causes the failure. I've got to change the process. And if that means changing a culture and changing their training and going to a different school to learn, that's what it means. And that'll affect, this is that effect, it's a global effect now. Better practices, more knowledge, more understanding, it's a global effect. If I train my guys to teach, to look after all their bearings properly, then all the machines improve over the coming years. And so I'm going to create reliability with better practices and better techniques. That's going to come back to me as a lot of money made very easily. That's how it'll go. Yes?
I wonder what the management and the engineering department thinks is causing their machines to fail. They think something is.
Remember, a bearing's designed to be underneath that the infinite stress zone. Now, a bearing should never fail in the service life of that machine. That's how it's designed. If it's failing soon, then it's being stressed from something. Something is causing it to fail. It's not natural. Something unnatural is happening to it. Now, if they can think that way, what is causing it to fail, that's a huge step forward. If they can at least ask that question and begin looking to see for evidence, that's a huge step forward in their thinking.
I think the risk matrix has to come into play here because I believe that most CEOs and managers, vice presidents at companies accept the fact that bearings fail. They accept it. It's part of the risk that is acceptable to them.
Yeah.
They need to be shown that this is unacceptable and what the value of it is.
Yeah.
I believe that.
I think that's how I saw it too, I must admit. And to me, you've got to be a businessman. You've got to have a businessman's hat on. And that's the best way to think. You know, the engineering's great, the reliability's great, but you've got to have a business perspective, and you've got to talk to it in their language. And if we engineers can't talk business language, then we're the ones that need to lift our game. Because if we can explain things and show, well, look, this training might take a year for your crew, it might take $100,000. But after the training, you're going to win back $10 million in the coming years. It's not too hard to make a business case. So got to build a business case around the true total cost the business is actually losing and how big their risk boundary actually is. Then I can begin putting this together into a solution and say, well, you can live in this world, but it will be the same forevermore. Or we can talk about trying some different ideas, some simple techniques that are global best practice changes, and let's see what that does to your business. So yeah, we hang the carrot out, and I think a very fair carrot, a very reasonable thing to try and do. As I say, I was an engineer for 52 years old. I've been an engineer for 22 of those, and it meant nothing to me until I began looking to see why things fail, and what do you do about it in particular. So yeah, this is how our tasks fail our machines.